part two of the morning session. I'm here to introduce Rama and her talk, Merging Cloud Native and Legacy Source Data Using Spark. Rama started her journey as a business intelligence engineer in India as a consultant for Tata Consultancy Services. After moving to the UK, Rama has been working for Swiss Re as a BI consultant before moving to advanced analytics for Quantum Black. Rama joined Direct Line Group in 2019 as a data engineering manager to start building their data analytics platform for their legacy and cloud data for DLG's motor insurance products. She started her journey of building this platform from understanding the requirements of users, recruiting a team, and working with the leadership to deliver a platform. If I can ask you to give a round of applause for Rama. Thank you, Rama.
Hi, you guys. Can you hear me? Good? Okay, cool. So one of the important things we aim to do at DLG, whatever we model, our data science function tries to do does it better with each iteration. We are DLG. We are one of the UK's one of the leading insurance providers in the market. I don't know, when we were standing at the booth below, not many of you knew what we did. We are an insurance firm, one of the leading ones. We have a lot of products brands that we sell: Direct Line, Churchill, Privilege, Green Flag. We have products like home insurance, car insurance, pet insurance, travel, and many others. We have a lot of channels through which we sell our insurance products. You can directly call telephonic, you could go to our websites, you could go to price comparison websites and look for quotes, and we are there. We have a lot of products. So all of this means we have loads of data to consume, process, create models, make it better, price better for the market and for the customer, give a fair value, etc. Today, I'm in the Data Science Festival. I would be presenting a data engineering lens as a data engineer. What do we do to make and process the data before a data scientist can use it? I'm going to take you through a journey of how we have taken our legacy systems to the new cloud-based platform and how we are trying to prove ourselves successful in this journey. So this is going to be a little bit of a storytelling. So prior to 2019, our policy system was a mainframe system. So all our policy was sold on a mainframe system. And to process data from mainframe, we had to use the SAS technology. So our data warehouse was SAS. From this SAS, any pricing analyst or any MI or a data analyst, if he had to analyze and understand what should we do to improve ourselves, they had to either go ad hoc querying on SAS, so they have to be SAS knowledgeable, or they had to generate Excel reports out of it. And later, over the years, we also invested into Click, which is an MI tool that could connect to Excel dashboards that could be generated out of this SAS. After 2019, we invested into a new policy system called Guidewire, which is Oracle-based. From this system, because we were investing anyways into a new policy system, we thought we also need to go big bang with cloud. And between AWS and Azure, obviously our company went for cloud AWS. We selected the AWS platform to host all our data from the new policy system, created a data lake, and from this data lake, any new policies that would be sold from our new system, analysts could access it via MI tools like Click or directly ad hoc querying, as well as connect their traditional modeling tools to it. There was one problem with this, however. Our old system was still live because we have so many products, so many brands. It was not an easy one to take all our brands to the new system. More so, I don't know how much you know about insurance, but insurance, if a policy or a claim is live, it can even go for 10 years plus. So to take an existing policy from an old system to a new platform, it would take us some time. More so when you do data science, right? When we create models, just having the brand new fresh data is not enough. You need to do a lot of statistical analysis on historical data. And all our historical data was in the old system. So now we have the big problem of how to merge all of this together. Because what our analyst used to do, or when the new system went live in 2019, he had to first generate a report or do some analysis in the new system, he had to do it from on the old historical system in SAS, merge it somehow together, and mostly it was manual, believe me, and generate and inform leaders to make the right decision, either change rules, underwriting rules, or change live pricing models, etc. So there came a conceptual idea of creating a uniform analytics platform. We called it the data analytics platform. The idea was simple: to get our legacy and our new systems data into one cloud platform. We called it the data analytics platform. We acronym as DAP. And the idea was we should move all our users, our data scientists, our MI reporters, our analysts to this platform to either start pointing their modeling to the platform, to do any ad hoc querying, build any new age models from it. Our ambition was also, because we were originally SaaS oriented, so our analyst profiles were also SaaS oriented, but our ambition was to even introduce Python modeling, etc., via this platform. This was only going to be possible if we were able to bring all our data centralized into this platform. This was the start of it. With that platform as an ambition, we obviously also divulged into what technologies we would like to invest in. Because we were already doing SaaS, one of the things was that we would not be able to easily migrate everything from SaaS to the new Python-based modeling. So one of the ambition was that old traditional SaaS modeling should also be able to consume from this new platform. We wanted to venture into Tableau because Tableau is one of the leading MI tools in the market, it's an easy front for MI. So we wanted to introduce Tableau because Tableau is also going very well with cloud. And we wanted to also move in a future arena to a new data science platform, which we have selected as Domino. So this is what is the goals that we started with, that we would migrate to a centralized cloud platform. We called it DAP, where all of our data would be centralized to. We would have MI into Tableau. Our old tools like Click and SAS would also be able to read it till we fully transformed into the new text tools. And all of this would be available to any kind of data analyst, pricing analyst, data scientist, new age data scientists. When we decided for DAP, we came up with certain goals. One was data availability. That's the most important one any data science would want. The data should be available in all its raw form and processed form, all in one place, and easily accessible. So that was our main goal. From a capability perspective, people had to do a lot of manual processing in one system, go to a new system, do the processing there, join it, and merge it together. So one of the important goals was that that capability should come up from this single platform where all of the ad hoc querying data science could be pointed to. It was very difficult in the legacy system to identify a data quality issue, to look through heaps and lines of SAS code to find out where the bug is and identify and solve it. So one of the things was that in this platform, we should be able to probably monitor and resolve our data quality issues sooner. So this was what we started with. So these are the goals we started with. And today, I specialize in motor business at the moment with DLG, so I'm going to take you through our motor journey. But we are doing a similar drive with our other brands and products as well. So one of the things that is very common in a big company like DLG is that if you want to invest and build a platform, you have to prove the case. And we had to select a use case to do that. In the selection criteria, we had to think about how are we going to bring the legacy data and the new system data into one place, create certain processes to make it repeatable and automated so that analysts could use it. So we came up with the concept of layering within the DAP. In every data engineering function in any company, this layering concept is very common. So whenever data is read first, it is first stored into a layer called stage, processed into a much more defined and standard format. We decided we would call it raw, and then process it into a little bit further layer called curated. After curated, we would leave it to the business. Like I work for motor, so we have a motor industrialized area created into the platform so that I could cater to the use cases for motor, but we have other industrialized areas for home, pet, travel as well on this platform. So the idea was to do this layering and create industrialized area within the platform. And all of this no longer in SaaS, no longer in pure SQL, it was pure PySpark code between the layers. And because we had selected AWS, we used services like Glue, Lambda, to do our processing between these layers. The utilities of this platform were also created ourselves. We used traditional Python utilities to create the functions within this platform. So, as I mentioned, to prove the case, we had to select a use case. So the first use case that we selected was fraud. Identifying fraud is a very common element in any insurance firm. We have lot of frauds that we have to deal with. And traditionally, when we used to identify fraud, it used to obviously be retrospective, because every time you get fraud, you want to make your underwriting rule, the rules that help you protect fraudulent behavior, better. And to do that in the old world, this image just represents the kind of processing that one had to do in SaaS. Each of this was isolated function in SaaS, which people used to run manually. And even if they were automated, the outcomes of this had to be processed and brought together. And then an analyst had to jumble this all up together into a dashboard to even look at, okay, what is the trend? How many people are we, how much of a fraudulent behavior are we having in the company? And what kind of changes we would have to make. So as a result of this, this was one of the most important use cases that we thought we should dwell into and probably prove it on the platform so that we can prove that it is profitable for the company in the investment of the data analytics platform. This represents what we ended up with. If you see, this jumbled up story was a little bit more streamlined by PySpark and Glue, and we created an automated and reusable process for fraud on the platform. Using this, the dashboard was, because it was automated, Tableau was connected to it, and we could actually start seeing live, frequently updating fraud dashboard for our users. This helped our fraud analysts to actually change underwriting rules more frequently than they used to. The difference between the old world and the new was that this processing took at least 24 hours to just get the output out of SaaS. And with the new world, it used to take 2 to 3 hours every day. This was a big benefit gain for our business and our company. And it absolutely proved the case for Motor. Motor is one of the most highest revenue generating product for DLG. So identifying fraud was one of the biggest use cases that we had to dwell with, and this was successful. So we went further. Risk modeling. In the insurance business, we have to look at how risky quotes are we giving to our customers. Are we making a terrible loss for the company, or are we making a profit? Are we giving a fair value to customers versus not? And it's a very common function in an insurance industry. This typically involves, if it was the legacy world, and it is still there for some of our brands who are still not migrated to our platform, we have to do a good chunk of data processing because it is mainframe data still in some of the brands. There's still SaaS processing still happening, which is a time-consuming. And coding in SaaS, I don't know how many of you are experienced, but coding in SaaS is complex. It is lines and lines of code that you have to write before you can actually schedule and automate it. Once that's done, the outcome of that is fed into live pricing models. in our company, we use Radar, but there are a lot of tools available in the market that can consume data sets from SAS, either converted to CSVs, etc., to do modeling. And modeling also looked like this. And if it was purely black box for anyone new who used to come and probably wants to investigate how to do this better. So having SAS already a complicated and complex programming enterprise, plus the old modeling tool was proving to be quite cumbersome. We decided to use a DAP, which is the data analytics platform, to make this life better. Because we were able to successfully bring the legacy and the new age policy system data into one platform, we were able to even think about processing the data for risk modeling as well. So we thought risk modeling would need a repeatable pattern. And in the old world, all this was done ad hoc. So when there was a need to improve the model, this had to be run manually by analysts, create the outputs, feed it into the modeling tool, and then generate the modeling score, look at the scores, and probably make decisions and changes to take that model to the live pricing model. In any insurance firm, you always have an offline version and a live version, where you try to train the model in an offline version, then take the model to the existing live one to predict prices during live. When a person comes for a quote to our company website, the model is spitting out live quotes to it. So this is that process of actually making that model better. And this was quite manual in its turn. Our idea was the offline scoring process should become automated, repeatable, and it need not be so complex that it cannot be debugged for data issues, etc. So on our data analytics platform, we did the layering concept, exactly similar. So our staging, raw, curated was exactly to read all of that data, process it in the shape and form that the model will expect, call the model automatically, which was previously manual. Now we had the capability to call the model automatically into the AWS cloud, execute the model, get the scores, and then and we could set this on a cron. Setting it on a cron meaning setting it on a timeline, repeated every day or as frequently as possible. So essentially, the process which was manual was now converted to an automated one. This was risk modeling. Similarly, we have our retail business. Retail pricing is about making are we doing better in certain products versus not? How can we sell more electric vehicles versus how can we improve in our selling insurance in our petrol-related vehicles, etc. So this involves a lot of price optimization. We have to create a lot of demand models, etc. And knowing that all of these models are still existing, in the legacy world, there was a lot of work involved into first generating the data from the old system, generating the data from the new system, merging it together, feeding it again to a live model, and creating modeling data sets and feeding it to the modeling tool. The biggest backdrop of these kind of processes is there is no way you find ways to automate when you have to deal with two systems unless the data is centralized into one certain analytics platform. And that was the main goal of the data engineering function where I was working within DLG, because with this platform, the objective was to bring the data to one system and probably cater to needs where people have to go to two different systems, merge things together, and automate it. So even with pricing, where we had to do processing of the data into two different systems and merging separately, we came up with this time, we wanted to also introduce our data science platform, the new data science platform, which we have selected as Domino, which will connect to the analytics platform, and all the processing, generation of the model input data set and creation of the model file would happen within this platform. This would not have been possible had we been still on the on-prem servers or on the legacy system where SAS was involved, et cetera. The possibility of having a new age data science tool like Domino, where there would be a lot of new capabilities of data science via Python possible, would only be possible due to the existence of this platform. So today, in DLG, we do have for Motor, we have the data science platform Domino, which has the capability of connecting to the cloud platform DAP, and which has the capability of creating model data sets and model files which can be executed into our live pricing models. So this is for retail, and that's about it.
Okay, so regarding the questions, because of the COVID risks, as you might have heard, we're not going to be chasing you around with mics, so you will have to yell your question, because it's a big room, and we all need to hear it, so make sure you belt that out. Okay, questions, hands up, please. No one at all?
But what I would like to say is that we have a booth downstairs. If you feel you want to know a little bit deeper into any of those, how we did it, what kind of practices we used, etc. We have a booth, we have a set of engineers, we have come along, we have our data scientists there. You could reach out, we are downstairs, and please come and visit our booth. Thank you.
Oh, look, we have a question.
Oh, we have. Oh, lovely. No, not in that sense. In fact, it's a great question, frankly. To do a reverse engineering kind of a project from SAS to New Age, we have two ways to do it. Either you start understanding what the SAS code is and start converting into New Age, which we initially started with. With our fraud use case that I was presenting about, we did that. It was quite a time-consuming effort. But with our new other use case that we have started putting onto our platform, we have started taking the approach of understanding the requirements from a user front, from an analyst front, rather than thinking of converting and like-to-like conversion of SAS to New Age. Because it's a very difficult process as engineers, because we are not necessarily SMEs of understanding what the model does, but when engineers want to write code in Python, etc., it's very much beneficial if we understand what we expect to spit out of the platform. So if you understand requirements from a user front, it's much better to model and code rather than reverse engineering an existing process and converting to a new age tech stack. Yes.
Final.
Is it possible just to elaborate on the layers that divided?
Yes, I could. This one? Yes, cool. Yeah, so this is quite industry standard to be fair, but we adopted this. So in our data analytics platform, we have layers called staging, raw, curated, and industrialized. Staging was for a place where we could have data sets coming in any formats, right? We had SAS. So we would have SAS data sets, we would have CSVs coming from our PCWs, we could have text files, etc. So we decided we would have a layer called staging, which would store the original form of our incoming data. So this was staging. From the staging, we decided to have a raw layer. Now this raw layer, in any cloud platform, you decide for a certain file type to consistently keep across in a data lake. We decided for Parquet. Parquet format has its own advantages of metadata stored in the file format, etc. Quite easy lineage possible, etc. So the first layer was raw, in which we converted any other format like SAS, CSV text into a Parquet format into raw using Glue and PySpark. From raw, obviously, we had data coming from channels like PCW, from telephonic stores, which were stored into the on-prem servers. We had data coming from our websites, like the directly. All of this would have the same kind of domain knowledge, like domain information like policy, claim, court, etc. Multiple sources would be centralized into common domain areas into the curated layer. So that is why we created the curated layer. And after curated, we decided to leave it to the business functions on how they want to use the data to cater to theirs. Like for example, motor has its own industrialized area, home has its own, and so other products and other brands. Did I answer your question?
Yep.
Thank you. Yes?
And do you grant access to staging to the end users, or are they only allowed to use the curated area?
Good question. So staging is absolutely not accessible to end users, but it is accessible to the data engineers at the moment. The raw and the curated is made available to the data scientists, but when it comes to MI reporting or analysts, only the industrialized areas is accessible.
Staging as well, we're making available for non-tabular formats, right?
Yeah.
So unstructured data.
So there's a lot of unstructured data in our staging area because it could come in any shape and form. And we didn't want to necessarily expose the intricacies and details of that to all the end users. So that's why. Great question, though. Yeah.
So if you have another, how do you deal with PII?
Great.
Where's the start?
Yeah. So I've not got the diagram shot, but we have obviously got PII data also coming in. These layers are nothing but S3 layers within AWS. S3 is a storage platform service within AWS. So within S3, S3 is anyways encrypted at rest, right? So when we get the data, the first thing we do is split the PII and the non-PII into the layer, keep it separate, and each layer has its, and it starts from raw, because we can't do that at the raw form. When we get a SAS data set, it will come as the source would send it, right? From raw onwards, we have our separate sections within S3 for PI and non-PI, so that due to retention or data privacy rules or compliance requirements, if we ever have to or decommission a certain section of the PI, we can delete or archive it. So each of our layers have our PI and non-PI sections separately. In the industrialized area, obviously there will be use cases where you would want to join it. So how would you join these together? Both the PI and the non-PI sections have their common key, which is what we call as the primary key, which is kept in both the sections of the data. Cool.
I think that's everything. Round of applause, please. Thank you.